this video, I'm going to prove the following theorem. It goes on to say the function tau and sigma are both multiplicative functions. I need to prove that. What is a multiplicative function? Well, if f of m times n is equal to f of m times f of n, whenever the GCD of m and n is 1, you have a multiplicative function. Now, what does tau mean? Now, before we talk about tau, I'm going to ask you guys to subscribe to my channel. If you like seeing mathematical proofs being done, this is the channel for you. Whichever video you click on, you'll see a new mathematical proof. Tau of n, so this is kind of review. Tau of n is equal to the number of positive divisors for n. That is, it's the summation of d divisors of n. We add up all the divisors of n. We add the number of divisors. That is, for each divisor, this is 1. So, if I wanted to know, say, where t of 6 is, well, the positive divisors of 6 are 1, 2, 3, and 6. So we're going to add up over all divisors of n, of 1. Well, that just means that we're adding up over those numbers. When d is 1, that's 1, plus. When d is 2, that's still 1. When d is 3, that's still 1. And lastly, when d is 6, how do you like that? That is also 1. Oh, 4. Oh, 4 divisors. Works perfectly. It adds up tau, adds up the number of divisors. It counts the number of divisors. If somebody tells you t of 6 is 4, or tau of 6 is 4, that means 6 has 4 positive divisors. Sigma of n is equal to the sum of all positive divisors of n. In other words, sigma, and this is equal to the sum of all divisors of n. The sum of d, where d is a divisor of n. So, sigma of 6, for example, sigma of 6 is equal to the sum of all divisors of 6. Maybe up here, right there, I should have said that n is 6. Divisors of 6. Here, we're going to add up the divisors of 6, where the function is d itself. So d can be 1, 2, 3, or 6. So when d is 1, that's 1. Okay? Summation, add. When d is 2, that's 2. Okay? It is what it is. When d is 3, that's 3. And lastly, when d is 6, d is 6. So we add these up, and if I do my math correctly, we get 12. Sigma of 6 is 12. Okay, remember, when d over here is any number, 3, whatever, this is always 1. It's a constant. Just like if you have the summation as n goes from 1 to 50 of 1. When n is 1, that's 1. Let me just go up to 5. When n is plus, When n is 2, this is still 1. When n is 3, that's still 1. When n is 4, this is still 1. And lastly, when n is 5, this is still 1. So we get 5. We keep adding up a constant. Okay. So now I explained what the tau function is and what the sigma function is. And I'm going to prove that both of these functions are multiplicative functions. Okay, so let's get into the proof of this. The cases when m or n or both are positive, it's kind of trivial. So let's start off with m and n are both positive, such that the GCD is 1. The GCD is 1 is necessary for us to talk about multiplicative. So the GCD of m and n is 1. Let's find the prime factorization. Let the prime factorization of m and n be, m say is equal to p1 to the r sub 1 times p sub 2 to the r sub 2 all the way down to p sub s r to the s, and let n equal q1 to the t1 times q sub 2 to the t sub 2 all the way down to, say, q sub u to the t sub u. So let's look at tau of mn. Tau of mn. This is equal to tau of m, p1 to the r1, all the way up to ps to the rs times this, q1 to the t1, all the way down to q sub u to the t sub u. Now, let's hold off on that. And I proved this theorem that I'm about to state, any divisor of mn must be in the form. Now, when I said that I proved it, I don't mean in this video, I mean in a prior video. Must be in the form of p1, say, to the a1 times p2 to the a sub 2 all the way up to p sub s to the a sub s times the q primes, q1 to the b1 all the way down to qu to the b sub u, where now I need to explain where these powers are allowed to live. Where a sub I, that is the powers of those p primes, has to be in between r sub I, or between 0 and r sub I. And the b sub i's must be between 0 and t sub I. That is, these powers have to be an integer, can be 0 all the way up to r sub I, I1. It can't be more than r1, because if this was p1 to the 7, how can a divisor have p1 to the 8 in it? Okay, so each of these powers, a sub 2, is less than or equal to r sub 2. It's between 0 and r sub 2. Okay. Now, let's talk about how many choices. So let's get back to yellow. Let's get back to tau of mn. Tau of mn. Well, every factor, every divisor of n, every divisor of n is in this form. Let that be written nicely. Every divisor of mn is in this form. So the question is, how many choices are there for each and every exponent? And the answer is, for this exponent a1, there are r1 plus 1 choices. For a sub 2, which is coming from p sub 2, r sub 2, we are going to pick from r2 plus 1 possibilities. How many possibilities for a sub s? It's going to be r sub s plus 1 times how many possibilities for b1? Well, it's going to be t1 plus 1. How many choices for b sub u? It's going to be tu plus 1 choices. This is exactly what tau of mn is. But now, I'll just rewrite this almost the same, one minor little thing. R sub s, t1 plus 1, all the way up to tu plus 1. I'm going to bracket it. These are real numbers. I can bracket it. Called dissociative property. Well, what's in the first set of brackets is just tau of m times what's in the second set of bracket is tau of m. So I proved that this is equal to tau of m times tau of n. And the GCD was 1. Okay, so I can check off tau. Now we need to do sigma. Well, sigma of mn, this is equal to p1 to the r sub 1 plus 1 minus 1, all divided by p1 minus 1. All that's for this first one here. And let's go to the last one for the p's. It's going to be p1 to the r sub s plus 1 minus 1 all over p1 ps, excuse me. Nope, pr. pr minus 1 times, now we go on to these. q1 t sub 1. Well, this is going to be q1 t sub 1 plus 1 minus 1 all over q1 minus 1. All the way down to q sub u t to the u, or t sub u. This is going to be q sub u raised to the t sub u plus 1 minus 1 all over q sub u, of course, all over cube sub u cubes of u minus 1. Mine a typo up here. Shouldn't be t times u. It should be t sub u. And just to save a little time, I could bracket it like this, and this here is sigma of m times this here, that's sigma of n. But that's exactly what I wanted to prove. It does turn out that the tau function is a multiplicative function, and the sigma function is also a multiplicative function. Is it always true? Like t of 4 times 5. Does this equal to, let me not do that. 4 times 6. Does it equal to t of 4 times t of 6? Well, let's see. What is sigma of 24? Well, the divisors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So sigma of 24, well, these two add up to 20. Let me put that there. 24 and 6 is 30. I love tens. 4, 7, 9, and 10. Okay, unless I made a silly mistake, it adds up to 60. Now, I'm going to claim that this is not going to work. What is sigma of 4? Well, the divisors of 4 are 1, 2, and 4. That's 7. And the divisors of 6 are 1, 2, 3, and 6. And if I remember correctly, this was 12. 7 times 12 is 84. Okay, so let me just write this slightly different. 7 times 12. 84, which is 7 times 12, which is our sigma of 4 times sigma of 6. Sigma of 4. Okay, so yeah, it doesn't work. Sigma of 24 is not sigma of 4 times sigma of 6. Why is that? The GCD of 4 and 6 is 2, which is not 1. If the GCD of 4 and 6 were 1, then I would not have the not equal to there. Just want to be clear that this is not always true. And likewise, if you look at tau of 24, 1, 2, 3, 4, 6, 8, 12, and 24. 1, 2, 3, 4, 5, 6, 7, 8. This is 8. And what is tau of 4 and what is tau of 6? They, after all, do multiply. 4 times 6 does multiply out to 24. Well, tau of 4, the divisors of 4 are 1, 2, and 4. So that's 3. The divisors of 6 are those numbers. There's 4 of them. 8 does not equal 12, which is 3 times 4, which is tau of 4 times tau of 6. Okay. Now, 24 is also 8 times 3, and the GCD of 8 and 3 is 1. That would work. Notice the GCD of 4 and 6, well, it's still 2, just like it was for sigma. So if you did 8 and 3, it should work out. That completes this video. Once again, if you like math like this, subscribe to my channel. Right now I'm doing a lot of number theory proofs. See you guys in the next video. Watch and learn.